This is SpaceTime Series 26, Episode 84. Coming up on SpaceTime, another milestone for NASA's Parker Solar Probe, discovery of Martian gullies that could have been formed by recent meltwater, and a new study claims that planet Earth was formed from dry, rocky building blocks, and the water must have come later. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Parker Solar Probe has now completed its 16th close approach to the Sun. The 16th orbit included a perihelion on June the 22nd, when the spacecraft flew to within 8.5 million kilometres of the Sun's visible surface, travelling at some 587,000 kilometres per hour. Mission managers report the spacecraft emerged from its solar close encounter healthy and operating nominally. Now, on August the 21st, the Parker Solar Probe will swing past Venus for its 6th of 7 planned gravity-assist flybys of the planet. To prepare for a smooth course, mission managers at the Johns Hopkins Applied Physics Laboratory ordered a small trajectory correction manoeuvre, the first in over a year. The Venus flyby will use the planet's gravity to tighten Parker's orbit around the Sun and set it up for a future perihelion at just 7.25 million kilometres from the Sun's surface. Now, as the Sun becomes increasingly active, this perihelion will be especially important for learning more about heliophysics. NASA's Parker Solar Probe was launched in 2018. Its mission to observe and study the Sun's corona. It'll ultimately come to within 9.86 solar radii, or 6.9 million kilometres of the centre of the Sun. By 2025, the spacecraft will be travelling at around 690,000 kilometres per hour at closest approach. Now, to put that another way, that is 0.064% the speed of light, and that'll make the Parker Solar Probe the fastest object ever built by humans. The 685-kilogram spacecraft will undertake a total of 24 orbits around the Sun. The near-Sun radiation environment is predicted to cause the spacecraft charging effects, radiation damage in materials and electronics, and communications interruptions, so the orbits will be highly elliptical, with only a short time spent near the Sun itself. Parker will trace the flow of energy hitting the solar corona and accelerating the solar wind. It'll study how energy from the lower solar atmosphere transfers to and is dissipated in the corona and solar wind. And it will examine the processes, shape and non-equilibrium velocity distributions observed throughout the heliosphere. Parker Solar Probe will also look at how the processes in the corona affect the properties of the solar wind in the heliosphere. It'll determine the structure and dynamics of the plasmomagnetic fields at the sources of the solar wind. And it will observe how the magnetic field in the solar wind source regions connect to the photosphere and heliosphere. Scientists want to know whether the sources of the solar wind are steady or intermittent, how the structures in the corona evolve into the solar wind. They want to observe the mechanisms that accelerate and transport energetic particles, and they want to study the roles of shocks, magnetic reconnection, waves, and turbulence in the acceleration of energetic particles, as well as the source populations and physical conditions necessary for energetic particle acceleration. And they want to look at how energetic particles are transported in the corona and the heliosphere. This report from NASA TV.
NASA's Parker Solar Probe is a mission to explore the Sun. How can it do that? Why won't the spacecraft melt? You can't face off with the Sun without packing the right gear. This is why Solar Probe is equipped with a white shield that reflects heat off the front and keeps things cool in the back.
The heat shield is made out of a couple of different materials. One is carbon-carbon, which is a lot like the graphite epoxy you might see in your golf clubs or your tennis racket, but it's just been superheated. The inside is a carbon foam, which is just another form of carbon and is actually about 97% air. It's a very lightweight way of making a very strong structure.
Nobody likes a needy explorer. Solar Probe can take care of itself, thank you very much. And that's because it has autonomy software that will keep its instruments safe and cool behind the heat shield.
We're too far away to joystick it into place, so it basically has to always be sensing whether or not the heat shield is in the right position and correct itself if it isn't. There are these things called solar limb sensors that are just poking out at the very edge of the shadow, And if those get illuminated, the spacecraft knows, oh, I'm going the wrong direction, and can actually right itself.
It's important to stay hydrated in the sun, even for a spacecraft. Solar Probe circulates water to keep the solar cells from overheating. It stays cool and keeps power.
So basically, water flows behind the solar rays and into the radiators, and so the water warms up when it's behind the solar cells, and then cools down up at the radiators, and so that heat transfer is happening a lot like the veins in your body.
Heat is not the same as temperature. Temperature is a measurement, but heat is energy transfer. This matters because Solar Probe will be visiting the sun's outer layer, the corona. Like all stars, the sun is made of plasma. How tightly packed that plasma is depends on the layer. While the sun's corona has a very high temperature, the plasma particles are fairly spread out. So even though the temperature in the corona is 2 to 3 million degrees Fahrenheit, the heat around the spacecraft is manageable.
The corona and where we're going is actually not that dense at all. There are only a couple particles. And so when we think about it, those are very hot, but we're not touching a lot of them. It's the kind of like when you put your hand into an oven, and the oven might be at 400 or 500 degrees Fahrenheit, but your hand isn't at 400 or 500 degrees Fahrenheit.
Thanks to its design and destination, this cool, confident spacecraft is all set to explore. We can just sit back and chill as Parker's Solar Probe takes the heat.
And in that report from NASA TV, we heard from Parker Solar Probe lead engineer Betsy Cogden. This is SpaceTime. Still to come, discovery of Martian gullies that could have been formed by recent meltwater, and the ongoing debate about where the Earth's water came from. Now, a new study claims the Earth formed from dry, rocky building blocks. All that and more still to come on SpaceTime. Scientists have discovered gullies on Mars that look like they may have been formed by recent liquid meltwater. The findings, reported in the journal Science, offer new insights into how water from melting ice could have played a role in the formation of ravine-like channels that cut down the sides of impact craters on Mars. Martian gullies look eerily similar to gullies that form in Earth, especially in the dry valleys of Antarctica. And we know the Antarctic gullies are caused by water erosion from melting glaciers. In order to work out what's going on, the authors built a model that simulates a sweet spot on the red planet, when conditions on Mars allowed the planet to warm above freezing temperatures, leading to periods of liquid water on Mars when ice on and beneath the surface melts. They found that when Mars tilts on its axis to 35 degrees, the atmosphere becomes dense enough for brief episodes of melting to occur at gully locations. They then matched the data from their models to periods in Mars history when the gullies in the planet's Terra Serenum region are believed to have expanded rapidly downhill from high elevation points, a phenomenon that could not be explained without the occasional presence of water. One of the study's authors, Jim Head from Brown University, says previous research has already shown that early in the red planet's history there was running water on the surface with valley networks and lakes. But all that liquid water was lost about 3 billion years ago, and since then Mars has become a polar desert. This new work shows that even after that, and in the recent past, when Mars's axis tilts to 35 degrees, it heats up sufficiently to melt snow and ice, bringing liquid water back until temperatures drop and it freezes again. The findings help fill in some of the missing gaps in how these gullies formed, including how high they start, how severe the erosion is, and how far they extend down the side of craters. Previous theories suggested that Martian gullies could have been carved out by carbon dioxide frost, which evaporates from the soil, causing rock and rubble to slide down slopes. But the height of the gullies made many scientists theorize that meltwater from glaciers had to be involved, both because of the distance they travelled down the slopes and how eroded the gullies looked. But proving that liquid water could exist on Mars since it disappeared so long ago has been difficult because temperatures typically hover about 70 degrees below freezing. But the results of this new study suggest that gully formation was driven by periods of melting ice, as well as CO2 frost evaporation in other parts of the year. The researchers found that this had likely occurred repeatedly over the past several million years, with the most recent occurrence about 630,000 years ago. They say that if ice was present in the gully locations in the areas they looked at when Mars' axis tilted to about 35 degrees, the conditions would have been right for the ice to melt, because temperatures then would have risen above 273 Kelvin, equivalent to 0 degrees Celsius. The study's lead author, Jay Dixon from the California Institute of Technology, says the study shows that the global distribution of gullies is better explained by liquid water over the last few million years. He says water explains the elevation distribution in gullies in ways that carbon dioxide simply can't. This means that Mars must have been able to create liquid water in enough volume to erode channels within the last million years, which is very recent in time on the scale of Martian geologic history. Despite doubts about meltwater being possible and scientists never being able to model the right conditions on Mars for ice to melt, the authors are convinced that their meltwater theory is accurate because they've seen these similar features firsthand in Antarctica. There, despite the cold temperatures, the sun is able to heat the ice just enough for it to melt and for gully activity to occur. The new study is a continuation of previous research the team started decades earlier looking at Martian gullies. In a 2015 study, they showed that it was possible there may have been many past episodes on Mars when water was able to form gullies, that's if Mars tilted enough on its axis. The findings encouraged them to model what that tilt was and match it to the locations and altitudes of gullies that have formed. This paper raises anew the fundamental question of whether life could exist on Mars, because life, as we know it, at least here on Earth, goes hand in hand with the presence of liquid water. Now, the authors say Mars will eventually tilt to 35 degrees again. It's just a matter of time. Head speculates there could even be a bridge between an early warm and wet Mars and the Mars we see today in terms of liquid water. He says everybody's always looking for environments that could be conducive not just to the formation of life, but to the preservation and continuation of it. Any microorganism that might have evolved in early Mars is going to be in places where they can be comfortable in the ice and also comfortable or even prosperous in liquid water. In the frigid Antarctic environment, for example, there are organisms that exist, often in stasis in the ice, waiting for the water to form. And so this study also introduces the importance of these gullies in terms of potential targets to visit during future manned exploration missions of Mars. This is SpaceTime. Still to come, the debate continues as to whether Earth's water arrived with the planet or came afterwards. And later in the science report, a new study suggests the precursors of life on Earth may have come about by meteorites or volcanic eruptions. All that and more still to come on SpaceTime. The ongoing debate about the origins of Earth's water continues with a new study claiming the planet got its water well after it was formed. Now, this contradicts a study released last week which suggested that water was already present in the material which formed the planet 4.6 billion years ago. And so this to and fro debate continues. Billions of years ago, in the giant disk of gas and dust that surrounded the early nascent sun, rocky materials that orbited around the young star became larger and larger as they created more and more material. Eventually, these coalescing bodies turned into planetesimals, and finally the planets, moons, and asteroids we see today. Scientists are still trying to understand the details of the process by which planets, including the Earth, were formed. Now, one way scientists can research how the Earth formed is by examining the magmas that flow up from deep within the planet's interior. See, chemical signatures in these samples contain a record of the timing and nature of the materials that came together to form the Earth. It's sort of analogous to how fossils provide paleontologists with clues about Earth's biological past. Now, a study from Caltech and reported in the journal Science advances claims that the early Earth accreted from hot, dry materials. And that indicates, or at least infers, that our planet's water, crucial for life as we know it, must have arrived later in Earth's history. While humans don't have the ability to travel deep into the Earth's interior, rocks from deep within the planet can naturally make their way to the surface in the form of lavas. The parental magmas from these lavas can originate from different depths within the Earth, such as the upper mantle, which begins about 15 kilometres under the surface and extends down to about 680 kilometres, or the lower mantle, which spans from a depth of 680 kilometres all the way down to the core mantle boundary, about 2,900 kilometres below the surface. Like sampling different layers of a cake, the frosting, the filling and the sponge, scientists can study magmas originating from different depths of the Earth to understand the different flavours of Earth's layers, the chemicals found within and their ratios with respect to one another. Now, because the formation of the Earth wasn't instantaneous and instead evolved materials accreting over time, samples from the lower mantle and upper mantle give different clues as to what was happening over time during Earth's accretion. This new study suggests that the early Earth was primarily composed of dry, rocky materials. Chemical signatures from deep within the planet show a lack of so-called volatiles. This new study suggests that the early Earth was primarily composed of dry, rocky materials because chemical signatures from deep within the planet show a lack of volatiles, which include easily evaporated materials like water and iodine. In contrast, samples from the upper mantle revealed a higher proportion of volatiles, 3 times those found in the lower mantle. Now, based on these chemical ratios, the study's authors created a model that showed Earth formed from hot, dry, rocky materials, and that a major addition of life-essential volatiles, including water, only occurred during the last 15% or less of Earth's formation. The study provides another chapter in the multitude of hypotheses contributing to scenarios surrounding how the planet formed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims that the precursors of the molecules needed for the origin of life on Earth may have come about because of chemical reactions caused by meteors or volcanic eruptions 4.4 billion years ago. The findings, published in the journal Science Reports, looked at whether meteorite or ash particles left on volcanic islands could have promoted the change of CO2 in the atmosphere into early organic molecules needed for life, which they tested by placing all of the ingredients under extreme pressure and heat. The authors found that these non-iron-rich particles helped in the conversion, and they may just be the building blocks for all living things we see on Earth today. Bit of good news for the, shall we say, gravitationally challenged. A new study has found that having a high body mass index probably won't lead to an early death if you're otherwise healthy. A report in the journal PLOS ONE looked at previously collected data on 554,332 Americans, dividing them into 9 different body mass index categories. They were studied between 9 and 20 years, and scientists found the risk of dying from any cause was similar across a wide range of body mass indexes. For older adults, death didn't increase for any body mass index between 22.5 and 34.9, which extends into BMI categories typically considered obese. For younger adults, there was no increased risk of any body mass index between 22.5 and 27.4. But overall, for adults with a body mass index of 30 or over, there was a 21% to 108% increased risk of death linked to their weight. And the patterns were found to be largely the same in both men and women and across races and ethnicities. The findings support the idea that body mass index alone may not be a reliable indicator of overall health. A new study indicates that the profile of scent compounds in your hands can be used to predict your sex with more than 96% accuracy. The findings, reported in the journal PLOS ONE, used an analysis technique called mass spectrometry to analyze the volatile scent compounds present in the palms of 30 men and 30 women. They identified the compounds in each sample and then used statistics to see if they could determine a person's sex based simply on their smell. And they got it right 96.67% of the time. The researchers say this technique could be used to help identify criminals when other evidence such as DNA is lacking, because crimes that involve perpetrators using their hands, such as robberies, assaults and rape, could potentially leave valuable trace evidence at the crime scene. Well, if you've ever done it, standing under the bright lights at the intersection of Broadway and West 45th in the heart of the Big Apple makes you feel like you're at the very centre of the world. But the problem is, it's no longer a place you'd recommend to friends, because New York City, once one of the greatest places on earth, is now a crime-infested squalor where criminal activity is skyrocketing, citizens are arrested for defending themselves from violent offenders, taxes are through the roof, and residents, well at least those who can, are leaving in droves for places like Florida and Texas. But for the mayor of New York City, the real problem appears to be the ghosts haunting Gracie Mansion, the official mayoral residence. Tim Mendham from Australian Skeptics says, for Mayor Eric Adams, it really is a city that never sleeps, even after death.
The mayor of New York City, who is Eric Adams, is a person with a very interesting history of his actions and his beliefs. Colourful is a nice way of putting it. He claims that the mayor's mansion, which I think is Gracie Mansion, it's called, is haunted. And he has made these sort of claims about other places before, actually, about different places being haunted. And he admits that people think I'm joking. He says, but there's a ghost that runs around here. And a guy running one of the world's largest cities would make you worried, actually, if he had this sort of he's not even doing it as a joke. He's actually quite serious about it. So anyone with that sort of sense of lack of restraint about what's actually really happening and lack of investigation is a worry.
Well, they call it the second most powerful elected position in the United States.
Yeah, outside of the president, yeah. The interesting thing is you go to any American city and you find a lot of public buildings and old buildings are supposedly haunted. It's become a thing. Whether it's a thing to raise money through ghost tours, I mean, you'll find museums, I think various New York museums, Washington museums, I think even the Smithsonian at times had a ghost tour. And you worry about that, but these are things, buildings and organisations made up of decision-making people, scientists.
You've done the ghost tours around London, wouldn't you?
I've done a little bit of a ghost investigation. I've done ghost tours around Sydney.
Oh, really? There are ghosts in Sydney as well?
There are ghost tours around Sydney. You go to the quarantine station, they've got quite an interesting ghost story.
Oh, right.
But it comes it's at night, and the stairs in the quarantine station are sandstone cut into the soil. You can easily go head over heels down this thing, literally. But yeah, in fact, someone thought I was a ghost because I sort of waved from the group, the tour group, and appeared at a distance, and someone said, "There's a ghost!" And they came closer and they realised, it was me. It wasn't doing it on purpose. I was just moving away a bit, having a look around. But anyway, it's so easy to convince people that there's ghosts. I get reports all the time of American buildings. There's hardly a city, large or small, in America, especially American, but it could be other places as well, that doesn't have a haunted house of some sort or another, if not several, if not quite a few. And they're not necessarily all old buildings. Sometimes they're fairly new buildings. This one in New York City is an old building, obviously. Old buildings tend towards that way as candidates for hauntings, but sometimes new buildings, and you wonder why, especially if the ghost died a long time before the building was built. But the ghost, the person involved. So therefore, you've got a New York City mayor who believes firmly that the place he's living in is haunted, and that probably just sort of sits on top of a lot of other strange decisions he's made that you said it's probably in character. Said, I think a building with this much history and how long it has been, I believe that there's an energy that you feel in here. When people hear of ghosts, they think of movies. Like, I think there's an energy that's in this building. And that's the mayor talking.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.